This is going to be a little video on lab 4.2. It's going to be a little instructional video for you guys. It's supposed to be an individual walkthrough. So you read these pieces of information. It's a review from the lecture notes, and it's also the instructions. So we're going to go over the instructions on each of these items kind of one by one, and I want you to fill in the missing blanks and the things that we don't do. Okay, so again, this is atoms and isotopes. Using your notes as examples, draw a carbon atom, here's the carbon atom, an oxygen atom, here's the oxygen, and a sodium atom. Label each atom with protons, neutrons, and electrons. When drawing electron shells, only 2 can occupy the first shell and 8 can occupy the second and third shells. So here are the atom roles. The first shell can hold up to 2, the second can hold up to 8, the third can hold up to 8 as well. So let's go ahead and do carbon as an example. There are 6 protons and there are 6 neutrons. Where do you find the protons and neutrons? You find them in the center of the atom, which is called the nucleus. So you can abbreviate and say I've got 6 protons here and I've got 6 neutrons. That's in the center. Now let's go ahead and draw the first shell. We have electrons to fill in now. We have 6 electrons, but the first shell can only hold how many, according to the rules? 2. So you can put 2 electrons here. That means 2 are going to be, we don't have to actually draw them E and E over here, but we're just showing that the first shell has 2 electrons. So that means we need to have a second shell because we have a total of 6 electrons. So if we have a total of 6 electrons, how many of those will fit in the second shell? We have a total of 6. We've used 2. How many fit in the second shell? 2 plus what will equal 6? And it's going to be 4 electrons. So I'd like you to do the same thing for the oxygen and the same thing for the sodium. Now, next is fill in the chart with the correct names. You could fill in the correct names for these according to your notes. Look at the prior atoms. Which atoms have the same number of protons and neutrons? You can answer that question. And add up all the positive and negative charges for each of the 3 atoms for hydrogen, helium, carbon, oxygen, and sodium. So we're going to fill in this entire chart. The whole concept of this is to show that an atom is neutral. Okay? What's the total number of positive charges for hydrogen? How many protons does hydrogen have? Hydrogen's going to have 1 proton. How do I know that? Go to your periodic table, and what element number is hydrogen? And it's element number 1. Well, how many electrons must it have? This is a neutral atom, so it must have 1 electron. So we've got 1 positive, we've got 1 negative, and the total charge is going to be 1 positive and 1 negative. Total charge is going to be 0. So for all of these, it's going to actually be 0, and you're going to go to the periodic table and go to helium, carbon, oxygen, and sodium. Find what atomic number it is, because remember, the atomic number is equal to the protons and equal to the electrons. So go to helium, it's element number 2, and it's going to have 2 protons, and therefore it's going to have 2 electrons, because the atomic number on the periodic table is equal to the protons and equal to the electrons. And if I have 2 positives and 2 negatives, therefore the charge is going to be 0. You'll go through these questions right here and walk through those. Here's another activity. Here are the rules. The atomic number is always equal to the number of protons, always equal to the number of electrons, because the number of positives must equal the number of negatives. Fill the numbers in the chart below with the protons and the electrons. We're going to do carbon here. Since electrons are so small they do not weigh much, most of the mass in the atom is due to the presence of the protons and neutrons. That's the nucleus. So the atomic mass, this is what we went over in lecture notes. The atomic mass is equal to the number of protons and the number of neutrons. So here's the mass. The mass is equal to the number of protons and the number of neutrons. This is the nucleus. This is the weight of the nucleus. This is the mass of the nucleus. The atomic mass can be found by looking at the desired element on a periodic table. the bottom number for each element is usually the atomic mass. Fill in the atomic number for each of the 5 atoms below, rounded to the nearest whole number. Okay, so let's take a look at carbon. Number of protons on carbon. Remember, the number of protons is equal to the atomic number. So you find carbon. Carbon is element number 6. Okay, I can also say that my number of electrons must also equal the atomic number, which is going to be 6, because carbon, the atomic number, is number 6. What is the mass of carbon? If you look at carbon on your periodic table, that again can be found on your class pages, that's going to be 12.011. This rounds to 12 as a whole number. Okay, so in this case right here, the protons and the electrons are equal, and it's also equal to the atomic number. However, the mass is going to be the sum. So you're going to have the number of protons, here's my protons, plus my number of neutrons. Protons plus the neutrons has to equal this number over here. Okay, so again, number of neutrons. Here's the rearranging of this formula. The mass is equal to the protons and the neutrons. So therefore, the protons is going to be equal to the mass minus the neutrons, or what we need is this right here. The neutrons is equal to the mass minus the protons. The mass of carbon is 12. Number of protons is 6. 6 plus what equals 12? 6 plus 6 is equal to 12. So I'd like you guys to fill in the rest of these according to those rules. The protons, again, can be found from the atomic number. The electrons can be found from the atomic number. The mass, or the mass number, can be found from the periodic table. And you have to calculate this, taking the mass, 12, minus 6. So you have to do that for all of these in this row. Okay, so you're going to look at element number 17 and fill this in. And you're going to be drawing an isotope. And this is something that we did in lecture as well. It's an isotope of carbon. This is going to be the C14, which we did in lecture. So go through the steps one by one by one, and I think you'll be able to fill in this chart. You're going to be filling in the protons and the neutrons, and you're going to be doing the electron shells. This next one, activity. Hydrogen exists in its atomic form and has 2 isotopes that are called deuterium and tritium. Deuterium has an atomic mass of 2, tritium has an atomic mass of 3. Draw these 3 of the simplest isotopes below. So hydrogen is element number 1, which means it has 1 proton. Okay? It also has 1 electron. And hydrogen, there are no more neutrons in hydrogen. It just has a single proton. But deuterium has a mass of 1. This is a mass of 1 here. Deuterium has a mass of 2. Tritium has a mass of 3. So remember, it's the protons and neutrons that make the mass. So deuterium, this is an isotope. And if you remember, isotopes, they do not change the number of protons. They do not change the number of electrons. So let's go ahead and draw those in. So I have a proton and I have an electron. What does change in an isotope is the number of what's? And you should be answering neutrons. Well, hydrogen has a mass of 1 because there's just 1 proton. This has a mass of 2. I can't add another proton because if I add protons, it's going to be element number 2, and I'm still in hydrogen, so it has to have the same number of protons. So it has to have a different number of neutrons. 1 plus 1 equals my mass of 2. I'm going to let you draw in the isotope for tritium over here. And you guys should be able to finish the rest of this according to this activity and the instructions. And I will be going over these in a key. So look for that a little bit later this week.